Today I'm going to talk about satellite orbit. Satellites are man-made objects orbiting the Earth. Satellites are used to study the Earth for communication and to observe the universe. What happened to the universe? Then we will know by having the satellite. And then the first satellite was the Soviet Sputnik 1, which launched in 1957. Since then, many countries have launched satellites, with more than 3,000 satellites orbiting around the Earth nowadays. Okay. These satellites orbit around the Earth in orbit ranging from 240 km to 36,200 km. Satellites are in low Earth orbit. They will travel at a very fast speed of 27,400 km per hour, so that they will not be pulled back through the atmosphere, to the Earth's atmosphere. So we have range from 240 km to 36,200 km. But the satellites that are in low Earth orbit, they have to travel very fast speed of 27,400 km per hour, so that they won't be pulled back to the Earth's atmosphere. The satellites are always in a circular motion with velocity, with the gravitational force between the satellite and the Earth. The satellites orbiting closer to the Earth is moving at high speed. The satellites orbiting further away from the Earth move at low speed. So we need to calculate the speed of the satellite required so that it won't be pulled back to the Earth's atmosphere. So we need to calculate and know the velocity. And then the diagram shows, this is the diagram that shows the satellite orbiting the Earth. The satellite that's orbiting the Earth. If the mass of the Earth is represented by M, capital letter M, the mass of the satellite is represented by the small letter m. And the satellite orbital radius is r. This is the orbital radius r. Hence, orbital velocity is derived. How was this orbital velocity derived? Is using the relationship between the Newton's universal law of gravitation with centripetal force. Centripetal force is here. And then the gravitational universal law of gravitation. Okay, let's see how to calculate the orbital velocity. We need the centripetal force equal to the gravity force, the gravitational force. As we know that the centripetal force, the formula is mv squared over r, equal to the universal law of gravitation, g, which is the gravitation constant, m is the mass of the Earth, and the m is the mass of the satellite, divided by the radius square. If we want to find the velocity, so we have to move the other factor to the other side. And then cancel out the same common factor. Then finally we get velocity equal to the square root of gm over r. Okay, as a conclusion, the orbital velocity v equal to the square root of gm over r is the velocity that required by a moving satellite to orbit the Earth in a circular orbit. This is why we have to learn how to calculate the orbital velocity. Is for the satellite, required for the satellite to orbit in a circular orbit. Thanks.